Hi, guys. Today we are going to start a completely new topic. And actually, the most exciting part is that this is our last concept we're working with for this year. Woohoo! Okay, we're going to go into inequalities, okay, over the next couple days. Okay, so we're all done with systems. The only thing that you have to focus on is getting that project in, which is due tomorrow. Okay. So today what we're going to do is we are going to work with writing, graphing, and one-step inequalities. Okay, so there's three different concepts we're going to be working with. Our objectives for today is for students will be able to write and graph inequalities by identifying keywords. And we're also going to solve one-step inequalities by applying inverse operations to isolate the variable. Okay, so first I want to take a minute and look at the inequality symbols, okay? So you've obviously seen these before, so I just wanted to go over each one. First, we have greater than, okay? Greater than, the opening comes first. When you graph it on a number line, which we'll revisit soon, but I just wanted to have this as a quick guide for you to always look back on during these next couple days. Greater than, it's going to be open circle, always shading to the right, because think about it, your numbers get greater as you go to the right. Okay. Also, when writing inequalities from a sentence, two key words are more than or greater than. Okay. Next, we have less than. I'm just numbering them just to show you where I'm talking about. The numbers really have no meaning to anything. Less than, you hit your point first. Less than has an open circle and always shading to the lesser numbers, which is to the left. Less than, left. Okay. Sometimes I always think, even going back to greater than, you see how this point is going that way? That's the way you shade. Less than, the point's going that way. That's the way you shade. And that's only if your variable comes first, like x is greater than 6. Okay, it would not apply if it's like 7 is less than x. Okay, you'd always have to flip that, which we'll talk about as we go forward. Next, we have greater than or equal to. So greater than or equal to, that is going to have the greater than, and then also the one line of an equal sign underneath. That's going to be a closed circle, because greater than or equal to, that means it could include that number that it's on. Okay, closed circle, shading to the greater numbers. Keywords, I'm sorry, I forgot to say keywords for less than. Keywords for less than could be fewer than or less than. Okay. As far as fewer than, if with all these regulations we have to follow right now with COVID, if you were told that you could have fewer than 10 people in your house, well, if you're told you have to have fewer than 10, then that means you have to have less than 10. Okay. For greater than or equal to, keywords are at least and also no less than. And finally, we have less than or equal to. So it shows the less than symbol with the one line of the equal sign. It's a closed circle shading to the lower numbers. And keywords here are at most or no more than. Okay. Again, with the no more than, we can apply it to, things that we have to follow right now. Governor Murphy the other day just said that you can have no more than 25 people outside in your yard, let's say. So if I said I can have no more than 25 people, well, that means that I can't have 26, I can't have 27, I can have no more than 25. I could have 25, but nothing over that. So it has to be less than or equal to 25. Okay, so it's always good to kind of think of a real life scenario or how you can relate that inequality just to kind of help you write them. Okay. So we are going to first practice a little bit with writing each sentence as an inequality. Okay, so what I like to do a lot of times is underline keywords, circle things, box things out. Okay, so what I like to do is I like to underline any words that represent a symbol that I would need. Okay, so if I have a number W minus 3.5 is less than or equal to -2. Well, I know less than or equal to, well, I'm going to put the sign underneath. Okay. I do like to then box my variable. So a number W, that's my variable. I'm also going to underline minus because that represents subtraction. A number W represents W. And I'm going to circle any numbers that I need. I'm going to circle my 3.5 and my -2. I'm going to put 3.5 here and -2 here. Well, would you look at that? I pretty much just wrote the inequality up above the sentence. So I'm just going to write it again. W minus 3.5 is less than or equal to -2. And there we go. Second one. 3 is less than a number n plus 5. I'm just going to change my color pen. So again, I'm going to underline any words that represent symbols or operations. So 3 is less than a number n plus 5. So I know I'm going to use less than. I know I'm going to have plus here. Now I'm going to box out the variable. So a number n, here's my n. And my numbers, 3, even though it's written out, it's still representing a number. I put that, and then I'm going to put 5. And here is my thing. 3 is less than n plus 5. Okay. You know what I'm actually going to do? I'm going to erase this and just move it closer just because I want to have some space for the next one. Okay, good. Okay, next. 0 is greater than or equal to twice a number x plus 1. Woo, this one's a busy one. All right, so let me underline any words that represent symbols or operations that I need. So we have greater than or equal to. So that means opening comes first, the one line of an equal sign underneath. Okay. Twice a number x plus 1. Twice is a little bit of a special case because it actually represents a number and an operation in itself. Okay, because if I have, twice the amount of people came, then it's actually double. So it also represents multiplication. Okay, so I'm going to just keep that in the back of my mind as I'm finishing up this. Okay, I have a number x. That's my variable. Now, again, twice a number x, again, you're doubling something up, you're multiplying. So I'm going to put a 2 in front of that x. And then I'm going to circle my word or my numbers, 0 and 1. So here we go. 0 is greater than or equal to 2 times x plus 1. And there we go. Okay. Good. Let's try another 2. Okay. A number B is fewer than 30.4. Okay, so I'm going to underline keywords. Now, fewer than. Okay, well, if you want, if you look back at our chart, fewer than is under the less than symbol. Okay, so use that as reference. I'm going to box my variable, a number B is fewer than 30.4. So B is less than 30.4. So that's actually just a standard inequality with no actual operations there. Okay, next. 5 is at least half the number K minus 4. Okay, so 5 is at least. Okay, so if something has to be at least, you know what I love to compare this one to? When you go to, let's say you go to Six Flags, or I know we love to take Brendan to Sesame Place. And at Sesame Place on each of the rides, and they do this at all the, amusement parks and that, when you see the sign of your height, and if it says you have to be at least, 32 inches. Okay, so you have to be at least 32 inches. Can you be 32 inches? Yeah. But you have to be 32 inches or higher. Okay. If you're 31 inches, you cannot ride it. But if you're 32, then you can ride it. Okay, so 5 is at least. So again, at least. Okay, so if you're thinking of this, which let's do the other stuff and then we'll think about what we're going to do. Okay, 5, circle 4, circle minus. I'm going to box the number K. And now half the number. Well, half the number you're going to multiply by a half. Minus 4. I'm going to put 5 here. Okay. And so again, if we have at least, we're going to look at greater than or equal to. Okay. Good. Okay. So next we're going to work in a situation where if they're telling us to see if a number is a potential solution for the inequality. Okay. Now, the difference between equations and inequalities is that, equations only have one solution. Okay. For the most part. Of course, you have, different things of no solution and infinitely many, but, overall, if you get x equals 5, then that means 5 is the only solution. But now with inequalities, you literally have endless amounts of solutions, okay? Because if you have, let's say, x is greater than 5, well, any single number greater than 5 would fit that inequality. So 6 would be a solution, 7 would be a solution, 5.1 would be a solution, 5.0023156 would be a solution. Okay, so any number greater than 5 would be a solution. So if we want to test a solution, okay, so we want to know whether -4 is a solution to each of these inequalities. So what I'm going to do, Pretty much the same with systems. We would substitute in the numbers and see if it's a true statement, if it works. So I'm going to replace the x with -4 plus 8 is greater than -3. I'm going to clean up. -4 plus 8 is 4, less than -3. And now what you want to do is you want to say to yourself, well, is 4 less than -3? 4 is not less than -3. So this would be no. Okay. Next, I'm going to substitute in -4 into x. Almost. Okay. And now what I'm going to do is this is multiplication. So I'm just going to jump off to the side. I'm going to multiply. 5 times 4 is 20. 4 times 4 is 16, plus 2 is 18. Remember, you count your decimal spots. 1 spot, 1 spot. So it's 18. Also, it's negative times a negative, which is going to be positive. Now, I'm going to ask myself, is 18 greater than -21? And yes, it is. So what that means is that -4 is a solution to -4.5x is greater than -21. Okay, so again, there's tons and tons of solutions. Okay, and we're just testing out -4. That's the one solution we're testing. Okay. So now would be a great time that if you want to pause the video and just try these on your own. Okay, sometimes I think that's good just to, try things on your own and see if you, understand the concept. Okay. Okay, so maybe you just press play again, and now you're starting up, and I'm going to show you how to evaluate these, and we're testing out -6 for all of these inequalities. Okay, so what I'm going to do is I'm going to plug in -6 into all of these. Again, you just clean them up. -6 plus 4 is -2. -2, now be careful, we have negatives. Is -2 greater than -1? No. So this would not work. Okay. Let's go over to the next one. I'm going to, again, plug in 3 minus, careful, you have a double negative here because it's a minus negative. I'm going to change that over to addition. Remember, we add the opposite. Leave, change, opposite. Now I'm left with 10 is less than or equal to 9. Is that a true statement? No. Okay. Okay, now I'm going to try the next one. 21 divided by -6 is greater than or equal to -3.5. So chances are you're like, oh, okay, that does not go in equally, but no need to fear. Jump to the side and just multiply 6 into 21. I know that goes 3 times, which is 18. 3 left over. I add my decimal and my 0. And I know it's 5. Now, don't forget it's a positive divided by a negative, so it's going to be -3.5 is greater than or equal to -3.5. So is -3.5 greater than or equal to -3.5? And this one is a yes, because it's greater than or equal to. Okay, so it can be the same number. Now, if by some chance, I'm just going to kind of go off into a cloud over here and think about a situation. If I had, let's say, 6 is less than 6, would that be a true statement? No, because it's 6 has to be less than 6. So it wouldn't. But the minute, if I added less than or equal to, then it would be a yes. Okay, so that's, that's always something to keep in mind. Okay. All right. Okay, so now let me do my last one. The 4 times 6 is 24 minus 25 is greater than negative 2. 24 minus 25 is negative 1. And we want to think, is negative 1 greater than negative 2? And the answer is yes. Okay, always remember with negatives, the smaller your number gets, it's actually bigger when it's in the negative. Okay? Good. Okay. So we have 2 more things just to go over today. Okay, I know it's a little bit of a longer lesson, but it's not bad at all. Graphing inequalities. So we use an open circle for less than or greater than, and that means that number is not included in the solution. We used a closed circle for less than or equal to or greater than or equal to because you are including that number in the solution. Okay, then less than or equal to or less than, you're going to shade to the left. Greater than or equal to, you're going to shade to the right. So here we go. Anytime you're doing this, whichever number you have that you're given, okay, so for example, it's y is less than or equal to negative 3. That's going to be, that negative 3 is going to be the number that I start with in the middle. And I always just kind of like to do 2 to the right, 2 to the left. So I'm going to count negative 2, negative 1, negative 4, negative 5. Now, if y is less than or equal to, that means I'm going to do a closed circle on negative 3. And again, as long as your variable comes first, see how this symbol is pointing to the left? Then I'm going to shade to the left. And I'm going to do the arrow too, because again, this keeps going on for different solutions. And then by looking at your graph, you can actually even tell me what a potential solution could be. So negative 4 could be a solution. Negative 5 could be a solution. Negative 256 could be a solution. Negative 3 can be a solution because it's less than or equal to. That's why we shade in the circle, because you're including negative 3. Negative 1 cannot be a solution. It's not a shaded area on my number line. Okay, now looking at the next one. Now, this is so bad. I hate when I see the variable comes second. So the first thing you want to do, because you do not want to start shading the wrong way because your variable is second. So I'm going to literally turn the entire inequality. And if you notice, you can see the opening is towards the x. So when I turn this all around, I'm going to put the opening to the x. Okay? So now I'm not even going to pay attention to that first one. So again, my number is 2. 2 to the right, 2 to the left, 3, 4, 1, and 0. Its x is greater than 2. So I'm going to do an open circle because it's greater than 2. It cannot be 2. 2 cannot be a solution. And again, now that I turned it over, okay, then I can see how it's pointing to the greater numbers. And yeah, it makes sense. X is greater than 2. Then we have X is greater than 0. Okay. I meant to erase. Okay. So I'm going to put my 5 lines, 0, 1, 2, -1, -2. So X is greater than 0. So greater, I'm going to do an open circle, shading to the right because it's greater. So again, a potential solution could be 1, could be 2, could be 1.5, could be 3.5, it could be 8, it could be 9.1. Okay, a number that would not be a solution would be -6, okay, because it's not a shaded area. Okay, so now here's another time that you might want to pause the video and do these on your own. Okay. Okay, welcome back. Hopefully you just unpaused your video because you just completed these on your own. So I'm going to start with the first one. I'm going to do -8, -7, -6, -9, -10. If B is greater than -8, open circle on -8, shading to the right. To the right, to the right. Okay. Next one. Ew. Yuck. I don't like when the number comes first. So I'm going to turn the entire thing around. I'm going to put the G first. Notice how the point is to the G. Okay. So I put the point to the G as well. Then 1.4. Now, decimals, you might be like, oh, man, what do I count by? Let's just count by tenths. 1.4, 1.5, 1.6, 1.3, 1.2. Now I'm going to go, it's less than or equal to. So I need a closed circle on 1.4, shading to the left. Okay, next one. R is less than 12, less than, open circle on 12, shading to the left. And then we have X is greater than -16. X is greater than, open circle on -16, shading to the right. Okay, awesome job. Okay, so now our last task that we're just going to do is now we're going to solve some one-step inequalities. Okay, so doing this, basically you solve the same as a normal equation, but treat the inequalities. So treat the inequality symbol the same as an equal sign. Remember, get the variable by itself. Okay, and then we're going to graph the inequality on the number line, which we already just tackled. Okay, so here we go. We are going to solve x plus 3 is greater than 12. So it's a one-step equation. I'm going to draw your line, box your variable. I'm going to subtract 3, subtract 3. X is greater than 9. And that's it. So then, just come on over here. 9, 10, 11, 8, and 7. If x is greater than 9, I'm going to put an open circle on 9, shading to the right. It's a bad arrow. Let's try it again. Awesome. Okay. Next one. So S minus 9. It's minus 9, so opposite would be to add 9 to both sides. Just be careful with your integer rules when you're doing these. S is greater than or equal to. So we have to think, what is negative 20 plus 9? Negative 20 plus 9. Same signs add and keep, different signs subtract. So different signs subtract. Keep the sign of the higher number, then you'll be exact. Okay? And then I'm done. The variable's by itself. So S is greater than or equal to negative 11. So here I go. Negative 11, negative 10, negative 9. Be careful with your number line when you're setting up negative numbers, okay? So S is greater than or equal to negative 11. So I'm going to do closed circle because it's greater than or equal to, shading to the right. Okay. Next, I have 5m is less than negative 25. Okay. 5m is multiplication. So the inverse of multiplication would be to divide by 5. So now I have m is less than negative 25 divided by 5 is negative 5. So we have negative 5, negative 4, negative 3, negative 6, negative 7. So it's less than. So we do open circle, shading to the left. Good. Okay. So this one might be like a, what do I do again? Okay, if you ever have a fraction as your coefficient in front of the variable, if you recall, you can multiply by the reciprocal. And that will cancel things out, leaving you x is less than or equal to. Now remember, this you could even just do what's 6 times 3 is 18. And then 18 divided by 2 is 9. So x is less than or equal to 9. Okay, so closed circle on 9, shading to the left. Awesome. Okay, and then one thing that I like to call a special case is always a scenario that, the rules don't work the same way or something special about the problem. Okay, so something to keep in mind is when you multiply or divide by a negative number, then the inequality sign will flip. So for example, if the inequality was less than, it would switch to greater than. So let me show you what I mean by this. Okay. So I have this negative 2, which is multiplication. See how it's negative? Okay, this is a special case problem. So I would choose to divide by a negative 2. But since I'm dividing by a negative number, my inequality sign would now flip and I would get negative 7. Okay. Okay, If D is greater than -7, open circle, shading to the right. We have -1/3 S is greater than or equal to 9. And again, the special case always works when the negative is with the variable. So here I'm going to multiply by the reciprocal, which would be -3/1. So again, since I'm multiplying or dividing by a negative number next to the coefficient, that is going to flip the inequality sign. And now 9 times -3 is -27. So closed circle, shading to the left. Sorry about that number line, that's very sloppy. And last example, m divided by 4 is greater than -2. So this is division. I'm going to multiply by 4 to both sides. Now, I chose an example such as this because sometimes then I find that when people see this is negative, then they think, oh, I have to flip the sign, okay? However, it's all about the number that is attached with the variable, okay? So this number attached with the m is positive. It's a +4 over here, okay? So in this case, I do not flip the inequality. Okay, so I'm going to do an open circle on -8, shading to the right. And, while I was, going through this, always as a teacher, sometimes you're like, oh man, wait, I should have did something like that, or, oh, maybe I should show that, and, whatnot. And one thing that dawned on me is that I didn't show you an example. I'm going to add on a bonus example for the day. Is let's say I have 10 less than m plus 6. Okay, so let's just say I have an inequality like this. So I'm going to solve. First off, there's no multiplication division going on, so I don't have to worry about flipping the sign or anything like that. Okay, the point of showing you this inequality, is the fact that your variable's on the right-handed side. Okay, so I just want to show you, and my biggest advice would be to just solve it first. Okay, so I'm just going to solve it. 10 minus 6 is 4, less than m. Okay, and looking here, now that I solved it, now I'm going to turn it around. Okay, and this does not mean flipping this symbol or anything like that. I'm just literally rotating the entire inequality. So I want the m to come first. So then this would be m. Notice how the opening is to the m. So I'm going to put the opening to the m. And then I'm going to put my 4. Okay, so if you ever notice the variable comes second or to the right-handed side, again, my recommendation would be to just solve it. Okay, and then rotate it around so the variable comes first. Okay, so now what? All right, you're going to complete the show off your skills Google form. Okay, you're going to be able to get 20 points for the day if you get a 10 out of 24. Okay, so if you get a 10 out of 24 for the day, then you earned your 20 points. And then don't forget to complete your daily check-in form. Okay, and again, any questions, just feel free to ask, okay? And if you are on this slide, then congratulations to you because you completed my entire video. Good job, guys. Okay, we're almost there. Keep on pushing through. You're awesome. Okay. Have a good day.